So we are looking at the EOC review packet number 64. We have a system of equations here. There are two lines. This one's in standard form. Second one is in slope-intercept form. So we can either graph, use substitution or elimination. I don't want to use graphing unless I have a graphing calculator. So I'm either going to use substitution or elimination. Substitution is your best method if one of the variables can be solved for easily, which means one of them has a coefficient of 1. In this case, this already has y by itself, so substitution is going to be my easiest option. I would have chosen to use elimination if both of them were in standard form. So step 1 of substitution is to get one variable by itself, which is already done for us. Now we're going to substitute that into the other equation. So I put parentheses and leave room here. Instead of y, I'm going to actually put negative 1/2 x plus 2. I'm going to substitute that expression. So now I have a multi-step equation to solve like chapter 2, beginning of the year. A positive times a negative is a negative. 2 times 1/2 is 1, which you don't have to write. And then I have an x, so that 1 is not necessary. Positive times a positive is a positive. 2 times 2 is 4. So I have x minus x plus 4 equals 4. Before you start moving things side to side, you need to combine like terms. Makes life easier. X minus x is 0, so I have 4 equals 4. Alright, the fact that the variable has added out means this is a special case. One of two things are happening. Either there's a false statement left, like 8 equals 17, and there's no solution because the original lines were parallel, or we're left with something true, like this, 4 equals 4, which means that these are actually two names for the same line. If you were to take this top equation and solve it for y, you would get y equals negative 1/2 x plus 2. These are the exact same line. It's just two different names. It's like calling you by your first name or calling you by Mr. or Miss last name. It's still you, it's just a different name. So that means that every single point, so the line looks something like this because it has a negative slope, every single point on this line is a solution to that system. Not all real numbers, because if there's a point over here or over here or over here or over here, they're not solutions, but any point on the line. So we generally use the words any point on the line back in chapter 6. But if you look at B, they're using set builder notation. The set of all ordered pairs such that, and then the standard form of the line. So such that it's on this line. So the correct answer for this one is B.